Okay, we're going to review the graph of the sine for a purpose today. So we said that any real number can be plugged into sine because any angle works, and angles and real numbers are the same. That the range is going to be from -1 to 1. The amplitude, the distance from the midline to the height, is 1. The period is 2 pi. We have intercepts for the sine, every single multiple of pi. So n times pi for any integer pi, for any integer n. The maxima occur at the odd numbers that are of the form 4n plus 1 times pi over 2. And the minima occur at the odd numbers that are 4n plus 3 times pi over 2. The sine is odd, and you can see that here in this small graph. In order to make the graph match, we would have to fold along the y-axis and then fold again along the x-axis. So anytime you twice fold to make it match, it's going to have symmetry with respect to the origin. That is the definition of odd. And let these folks in. And we know that that means that sine of negative x is negative sine x. Hey, everybody. Ben, may I make you co-host? I'm making you co-host. Okay. So in light of all of those things, and in light of these instructions that we have for graphing the sine, let's see which function was it that was the reciprocal of sine?
Cosecant.
Cosecant.
Cosecant. Okay, good. So let's look at graphing cosecant, because we're going to use this information that we have for sine. Sine has a domain of all real numbers. We almost have that same, wait, it's telling me something. Okay, we almost have the same domain for cosecant, except that cosecant is a reciprocal. So every time sine is 0, cosecant isn't defined. So that means every single time that we have an x of the form an integer times pi, cosecant isn't defined, and that's exactly what it means to have an asymptote. So let's just look at that part of the graph. At x equals 0, at x equals pi, at x equals 2 pi, negative 2 pi, there's going to be an asymptote for cosecant. Do you see the sine function in there? It's smaller than I wish, but okay, so let's keep going. The range of sine is -1 to 1. When you find the reciprocal, that means that the range of cosecant is everything else. So -infinity to -1, but we include -1, together with 1 to infinity, and we do include 1. So it's everything else. And it's important to remember, although we talked about it, that cosecant is not sinusoidal, and only sinusoidal functions have amplitudes. So cosecant does not have an amplitude, even though sine does. The period is still 2 pi. And it doesn't have intercepts anymore, but the intercepts for sine give us the vertical asymptotes for cosecant, and I didn't put it on here. And the maxima and the minima match up. So the points at the max and the min of sine and cosecant match. So we've got shared points. So let's do this example, and I'm actually going to make it, I'm going to change this to cosecant so we can do 2 examples with cosecant. So it is no longer sinusoidal. So we're going to graph the function -3 cosecant of 2x plus pi over 6. And the first thing that we're going to do is graph the related sinusoidal function. Which for cosecant will be sine. So we're going to graph -3 sine of 2x plus pi over 6. And for graphing sine, the first thing that we're going to do, let's have this one big one, and then a little or smaller one inside that. How about a different color? Okay, so now we want to identify A, B, C, and D, where the form is y equals A sine B times X minus C plus D. Okay, so what is A, what is B, what is C, and what is D?
A is -3. B
B
is
is
2.
-2.
C is -pi over 6.
Excellent,
And D is 0.
excellent. Hi, Ben.
Hello, sorry, my mic wasn't working at the beginning. Being
That's
co-host is
okay.
fine.
And hi, Sir Ralph, and I see Lynette, and I know the rest of you are there, but it's just nice to see you. Okay, so now that we've got that, let's plow through our steps, and I'm going to pull them back. We know the amplitude is the absolute value of A, the period is 2 pi over the absolute value of B, and the horizontal shift is phi, or phi, which is C over B. Let's do that part. The period is 2 pi over the absolute value of B. Why do we have to have absolute value in that formula?
Because the answer will be positive.
That's right, exactly right. Hi, Lynette. Because period has to be positive. So on the possibility that B is negative, this whole thing has to be positive. Beautiful. So we've got 2 pi over 2, which is pi, and I skipped amplitude. The amplitude is the absolute value of A. Again, why do we need absolute value?
Because amplitude is always positive.
That's right. That's exactly right. We know that phi, and why doesn't phi have absolute value in it?
It can be negative or positive.
That's right. It's the horizontal shift. If it's positive, it goes to the right. If it's negative, it's a horizontal shift to the left. This time B is 1. Oh no, B is 2. Oh, goody, goody. Okay, so we've got negative pi over 6 divided by 2, but I'm going to use the thing that helps me out a lot. Division is the same thing as multiplication by the reciprocal. So this is the same thing as multiplication by the reciprocal. And it not only skips a step, but it connects multiplication and division. And so now we see that the horizontal shift is going to be negative pi over 12. What direction will we be going then? Will we be
Left.
shifting? That's correct. That's correct. Because there was a plus in the middle here in the original function, we're going to be shifting to the left. We're just going to say D is 0, so there's no vertical shift. And now let's do the points. So we've got, oh, we didn't do P divided by 4. We said that the period was pi. And why is that important? Why does it help to have P over 4? Thanks, Ben. Why does it help to have P over 4?
To find
Is
the
the
4 quadrants.
yeah.
Yeah, to find the 4, not really the 4 quadrants, but the 4 critical points. The because we know that sine changes from an intercept to a max, to an intercept to a min, to an intercept to a max. Yes, that's correct. Very good. So this time, to make our math cleaner, we're going to do the fractions to the side. So we start at 0 times pi over 4 plus b, 0 plus d. 1 times pi over 4 plus b, comma, a plus d. Two times pi over 4 plus v, d plus 0. 3 times pi over 4 plus v, negative a plus d, and 4 times pi over 4 plus v, 0 plus d. Okay, we know that d is 0, so I don't know why I bothered putting all those d's in. But we're going to be really happy that this pattern tells us that we're starting at, when we go to the first extrema, a is negative, so the first extrema is going to be a minimum. So we don't have to remember that. We just use this pattern. So let's write in the fractions. So we've got, well, the first one is just b, which is negative pi over 12, 0. And then we've got pi over 4 minus pi over 12. And what do we need to multiply pi over 4 by to combine it with pi over 12?
What was the question?
What can we multiply pi over 4 by so that we can combine it with pi over 12?
3.
Good. And that's because 4 times 3 is 12. And once we have the same denominator, we can combine. I'm using the word combine rather than add since we're subtracting. So we've got 3 pi over 12 minus pi over 12. And that 3 minus 1 is, I'll write it down. 3 pi, yes.
Ah.
Minus pi over 12 is 2 pi over 12. And can we reduce that?
Yes, we can reduce it to pi over 6.
Excellent. We said that A was -3. So we have -3 as the next Y value. And now we've got I'm not going to reduce this 2 pi over 4 because I know I need to combine it with pi over 12. And anything I can do to make this process the same, I want to do it. So I was able to multiply pi over 4 by 3 over 3. Can I do the same thing with 2 pi over 4?
Yes.
Good. So this time we get 6 pi over 12 minus pi over 12, and that gives us
5 pi over 12.
beautiful. So this point will be 5 pi over 12 comma 0. Now we have 3 pi over 4 minus pi over 12, 3 over 3. That gives us 9 pi over 12 minus pi over 12. That gives us
8 pi over 12.
Thanks, Sir Ralph. And can we reduce that?
Yes.
By 4. Okay. So now we've got 2 pi over 3 and negative A. Well, A was negative. So what is negative -3? There it is. What is negative -3?
Positive.
Positive?
Thanks.
No.
Yes. And finally, we have pi over 4 times 4 plus B. So that's 4 pi over 4 minus pi over 12. We get 12 pi minus 1 pi, and that leaves us with
11/12 pi.
good. Thanks, Sir Ralph. So our final point is 11 pi over 12 comma 0. Is it cleaner to do the fraction mathematics to the side? Or was it cleaner doing everything at the same step?
I'm not sure what you mean by that.
So this time I did all of the arithmetic on a separate page and just filled in the answers. Yesterday or Monday, I did all of the arithmetic and had the answer on the same line. Which do you think is easier to follow?
I'd say this one is.
Yeah, this one right here.
Yeah.
Okay,
this one's-
good. Okay, groovy. So that gives us 5 points, but you're thinking to yourself, I didn't want to graph sine, I wanted to graph cosecant. Let's just give ourselves some axes, and those are not very good axes. The y-axis goes up to 3 and down to -3. And the x-axis starts at -π/12. And then π/6. There's a π/12. π/6. π/12. We go to 5 π/12. So this is 2, like 2, 3, 4, 5 π/12. And then 2 π/3. So 5, 6, 7. That's 8 π/12, which is 2 π/3. And then we stopped at 11 π/12, I think. Yes. 11 π/12. So I just counted by π/12 because I remembered that that's our smallest unit. And now I don't have to do very much. I can just plop in some values. So let's see. At -π/12, the y value is 0. At π/6, we have -3. At 5 π/12, we're back to 0. At 2 π/3, we're at 3. And at 11 π/12, we're back to 0. And when you're graphing these things, please don't just connect the dots. Make the graph smooth and continue it past the last point and prior to the first point, just so that you remember by doing that the sine goes on and on. But again, I hear you saying, no, we were trying to graph cosecant, not sine. Well, we've done all of the hard work. Every single place that sine is 0 will have a vertical asymptote. Every place that sine has a max, we have a shared point at the max, and cosecant goes up. Every time that sine has a min, we have a shared point with cosecant, and cosecant goes down. So cosecant goes up from a max and down from a min, and that's it. We're done. So the most important part of graphing cosecant is graphing the sine that underpins it. Let's look at a pretty version of that. Or not. Yeah. That's incidental music. Y'all are probably too young to remember that. Oh, here we go. So we started the notes had sine, and all I did to include cosecant was plop in asymptotes every time that the sine is 0, put a shared point at a max and a min. Cosecant goes up at a max, down at a min. That's it.
So is that what we would do if we have to plot cosecant? We would plot sine and then add those things that you're adding in, the
Yes.
asymptotes. Okay.
Yes, because otherwise, well, you're just plotting points and they're not as meaningful. And you can see even in the definition, and this was the nicest graph I could find online, but even in the definition of the graph of cosecant, they've got sine. So the graph of cosecant is based on the graph of the sine. And then you just add asymptotes, and then you just add shared points. Cosecant goes up at a max, down at a min. That's it. The other thing that I want to make clear is that the asymptotes, we said that's when x is, or when sine is 0. If there's a vertical shift, if d isn't 0, we're going to put those asymptotes as if d is 0 and then shift. And I think we'll do that in the next example. So let's graph y equals the cosecant of x minus pi over 4 plus 3. What are A, B, C, and D?
Is 0.
Almost.
I is 1, right?
Yeah.
B is also 1. C is the 1 over 4.
Pi over 4.
Pi over 4.
D is 3.
Yep.
Excellent. Excellent. So that means, and even though cosecant isn't sinusoidal, we're still going to talk about an amplitude, but what is the function that has the amplitude? Is it cosecant?
We believe.
It's the underpinning, it's the sign that underpins cosecant that has the amplitude. So even though cosecant is not sinusoidal, we are going to graph the related sinusoidal function, which we've said a million times is y equals sine x minus pi over 4 plus 3. Why is it not wasting time to graph this sine function?
Sorry, could
In
you
other
say that
words,
one more time?
sure, Why is it not wasting time to graph the sine function if we want the cosecant?
Make it easier for yourself to find the points, I'm guessing.
Yes, and the graph of cosecant is based, it overlays the graph of sine. So in order to graph cosecant, you have to graph sine. Okay, so we've got the period we know is just going to be 2 pi since b is 1. The amplitude of sine, since a is 1, we get 1. Now, b, that's c over b, but b is 1, so it's just going to be pi over 4. The vertical shift is 3. And so we've got the points. Oh, and the period divided by 4, it's 2 pi divided by 4, which is
1/2.
Pi over 2.
good. Oh, go ahead and sign in, everybody. You don't have to put your student number anymore, but just sign in your names. So we know where we need. We get 0 times pi over 2 plus b comma 0 plus d, 1 times pi over 2 plus v, a plus d, 2 times pi over 2 plus v, d plus 0, 3 plus times pi over 2 plus v, d minus a, or negative a plus d, same difference, and 4 times pi over 2 plus v comma d. Let's see, we said that b was pi over 4. 0 times pi over 2 is 0, so plus pi over 4 is just going to be pi over 4. We said that d was 3, so this is going to be pi over 4 comma 3. Now we have pi over 2 plus pi over 4. And what can we multiply by so that we can combine these two?
Two.
Good. And that gives us 2 plus 1 is 3 pi over 4. One plus 3 is 4. We're going not to reduce so that we can use the same pattern. So we have 2 pi over 2 times 2 over 2 plus pi over 4. That's 4 pi over 4. And d is 3. Then we'll have 3 pi over 2 times 2 over 2 plus pi over 4. And that's 7 pi over 4. D is 3. 3 minus 1 is 2. And then we'll have 4 pi over 2 times 2 over 2 plus pi over 4. And that's 8, 9 pi over 4. So we've got our 5 points. Let's see, I'm going to make this 4, 3, 2, and that's 1. Because I want to have room for the cosecant on top. So let's see, we start at 6 pi over 4, that's 3 pi over 2. Okay, now we have our point at pi over 4 comma 3. We have our point at 3 pi over 4 comma 4. We have our point at 5 pi over 4 comma 3. 7 pi over 4 comma 2. And 9 pi over 4 comma 3. And this time what I want to do is sketch in a midline. This midline shows what would have been the x-axis if we had not had a vertical shift. If D had been 0, this midline would be the x-axis. But this is important because cosecants asymptotes are still based on these intercepts. Even though they're not at the x-axis, the places where the sine curve crosses its midline still gives us the vertical asymptotes for cosecant. And then we have a shared point at the max, cosecant goes up, shared point at the min, cosecant goes down. What does an asymptote mean?
The line that the where the graph doesn't touch.
That's right. That's right. It's the line where the graph gets close, so close it almost looks like it's touching, but it never touches. It cannot touch. Very good. Okay. I have somewhere an assignment for y'all. Or maybe I'm just going to make it up. So I want y'all to do, just try this one. Graph y equals 2 cosecant x minus pi over 6 minus 3. Can y'all see it?
Yes, ma'am.
Okay. I'm going to be here, but I'm going to turn off my mic so that y'all can talk, and I'm pausing the video.
I had to step away for a second. Can
Sure.
we go over what the points ended up being?
Yeah. See if I can find a blank back. Here we go. So the try this was y equals 2 cosecant x minus pi over 6 minus 3. And that means that we're first going to graph 2 sine x minus pi over 6 minus 3. And we can see that A is 2, B is 1, C is pi over 6, and D is negative 3. The period is going to be 2 pi, and the period over 4 is going to be 2 pi over 4, or pi over 2. The amplitude is 2. V, which is C over B. B is 1, so it's just going to be pi over 6. And D is negative 3. That's everything we need to fill in our 6 points. So we have 0 times pi over 2 plus V, comma, D. 1 times pi over 2 plus V, comma, D plus A.
Oh, I'm sorry. Should I be able to see what you're writing right now? Because my screen is
Yes.
black.
You don't see it?
No, is it just me? Can everybody else see it?
We can see it.
What in the
I can
world?
also see it.
Sorry.
You
hold
can't
on.
see it, Ben?
Can
But
see it.
Ralph, Sir
No,
Ralph, you
it's
can
just
see it?
me. I'm the only one who can't.
Ben and I can see it.
Okay.
Sorry.
Lynette, what can we do?
Sorry. Hold on. Let me see if maybe let me. I'm so sorry, guys. I don't want to hold everybody up.
Oh, you're
No,
fine.
it's important.
Fine.
It's very important.
Why can't I see the screen?
Do you
Maybe try leaving and then rejoining.
yeah, that's I was just gonna say. Do you
Okay.
mind checking back in?
Yep, let me do that.
Okay. She's having connection issues.
Yeah, maybe.
That's a probability.
There she is. Hi, Lynette.
Hi. Okay. I can see it. I'm so sorry. I can see it now.
Okay, great. No, don't apologize. I'm glad that you let me know. So let's see, we've got 2 times pi over 2 plus phi, and this one is 0 plus d. So it's always 0, a, 0, negative a. 3 times pi over 2 plus phi, negative a plus d, and 4 times pi over 2 plus phi, d. What is the 5-point summary?
Are you asking for the equation?
No, what is it? What does it mean, the 5-point summary?
It's the 5 points in the graph.
That's right. These 5 points. 0, 1, 2, 3, 4 times 1/4 of the period. Now, 0, 2 is just 0, pi over 6, and d is negative. Now we've got pi over 2 plus pi over 6. I'm going to multiply pi over 2 by 3 over 3. Why am I doing that?
So that you can multiply pi over 2, sorry, add pi over 2 to pi over 6.
Good, good. So I've got 3 pi over 6 plus 1 more. That's 4 pi over 6, which can be reduced to 2 pi. D was negative 3. E is 2. Let's see, we've got negative 3 plus 2, which is negative 1. Now we've got 2 pi over 2 plus. Again, we multiply by 3 over 3. That gives us 6 pi over 4.
Miss, your audio is glitching out.
Okay,
Yeah, it's glitching out again.
a lot.
Yeah, quite a bit.
Closing some things. Let's see. If that helps. Okay, how is it?
It's still quite glitchy.
Yeah.
Oh gosh.
I can make out some words.
I tell you what, stop this video. I'm going to stop recording, finish up describing what's going on here,